Good greetings, guys. I don't I don't always like to say good afternoon, good morning, or good evening because I don't know where you are. So greetings, guys. Hopefully you are doing well. This is our Unit 9, Handout 9, or whatever you may refer to. This is our DIT 230, BIT 140, which is data communication as well as networking. Our Unit 9, we are looking at extending local area networks. We extend local area networks through fiber modems, through repeaters, through bridges, as well as through switches. So in this lesson, we'll look at how you can extend a local area network. Remember we said a local area network has to do with a small geographical area. So when we are looking at local area networks, one thing we need to bear in mind is that these cables, I think I should have explained at some point, the cables that we use in local area networks, they have a limit. Let's say UTP. UTP, you cannot use UTP from one point to another if that UTP is longer than 100 meters. As long as that UTP becomes longer than 100 meters, then there is a possibility of the signal, the network signal, to be lost. But imagine a place like CBU where you have offices which are 100 meters apart. There is need of extending that local area network. And part of the things that I use to extend that area networks, we have fiber modems, we have repeaters, we have bridges, as well as switches. So in as much as this cable can only work by giving us good network connectivity, up to 100 meters, for example, for UTP, you can still extend. Maybe when it reaches 95, you put a repeater there, or you can put a bridge there or a switch there, so that you just do a connection. The other cable starts after the 95. Again, after 95, you provide a switch, a bridge, a fiber modem, or as well as a repeater. Okay, so like I'm from mentioning, here we are saying distance limitations and LAN design. So distance limitation is a fundamental part of all local area network designs. When designing a network technology, network engineers choose a combination of capacity, maximum delay, as well as a distance achieved at a low cost. The two most popular access mechanisms that are there are carrier sense multiple access with collision detection, which we looked at, whereby before a computer or a device sends something on a network, it will sense to see if the network is free. If the network is free, then it starts to transmit. But I also mentioned earlier to say there are possibilities where two devices check if the network is free and they both think it's free, then they send at the same time. Then this CD part of collision access, multiple access comes into play. When there's a collision, there's a mechanism of how to resolve that collision. I think in handout 6 or 7, we looked at carrier sense, multiple access with collision detection. We also have token ring passing. In the star topology that we looked at in the previous handouts, there is no, in the ring topology, sorry, not the star topology. In the ring topology, when a machine needs to send, a token will be given to it to show that this is a machine that rightly needs to send. So if that machine has a token, then it will be able to send data at that particular time. So the token will be pushed in the ring to the next node. If the next node doesn't have anything to send, then it will push the token to the next machine just like that, until the token goes around that ring topology. So to ensure that delays do not become significant, a local area network technology works with a fixed maximum cable length. So a local area network works with a maximum cable length. I've said for UTP, it's 100 meters. You should be able to research how many meters or kilometers fiber can accommodate, STP as well as coaxial. But I've said for UTP, when you're using it in a local area network, the maximum cable length is 100 meters. After 100 meters, your signal will become weak. It's just like if you've noticed, like you have a hose pipe. When you connect it to this tap, if a hose pipe is, let's say, 3 meters, when you open your tap, the pressure will be too much. But the longer the hose pipe, if your hose pipe is 500 meters, you find that by the end of the tap, by the end of the hose pipe, the pressure will not be that big, that much, sorry. This is the way even networks work. So the shorter the cable, the better the connectivity. The longer the cable, the worse the connectivity. So if this cable can accommodate 100 meters, and then you push 120, the signal may not be as good as if you used 80 meters of that cable. Another limitation arises because hardware is engineered to emit a fixed amount of electrical power. A signal gradually becomes weaker as it travels along a copper wire. And we're saying UTP is one of those copper wires. So as the signal travels, it loses its strength. So this signal cannot reach a very far, cannot travel far, if I may put it in simple terms. Okay, so to ensure that all stations attached to a local area network receive a significant or a sufficiently strong signal, we need to calculate the maximum length of every cable and continuous stressing for UTP, the maximum capacity or signal length they've said is 100 meters. Remember, we have cables like fiber, we have UTP, we have coaxial. Coaxial, UTP, STP, they use a copper wire. Fiber uses glass, okay? So fiber optic extensions, if you need to extend fiber optic, how do you do it? So engineers have developed a variety of ways to extend local area network connectivity. Most of the mechanisms use additional hardware components that can relay signals across a longer distance. The simplest mechanism inserts optical fiber and a pair of fiber modems between a computer and a network. Fiber has a low delay as well as it has high bandwidth. The mechanism which operates correctly across distances of several kilometers. The most common use of connecting buildings right now is fiber. So you find that even in our setup, let's say at the Copperbelt University, we have buildings. Let's say the lab that we were using, Lab 3, and the main computer lab where almost all our servers are placed. The distance there is more than 100 meters. But with fiber, you find that fiber can actually do a connection from Kitwe to Ndola. I'm sure you've seen in your day-to-day life, there are those people that dig trying to push fiber. Sometimes they use poles to move fiber from one place to another. So just like even in our setup, it won't be appropriate for us to use UTP to connect to buildings. So we end up using fiber to connect these buildings. Okay, so in this figure here, this is a fiber modem that is here, as well as this is a fiber modem, and then this is fiber. So this fiber modem, what basically happens is it converts, it has two connectors, a connector that you can use to connect fiber, as well as a connector that you can use to connect UTP. Because remember, most of the computers that we are using right now support only UTP and not fiber. So you can have this fiber connecting two buildings, but when you reach the other side of a building, there's a modem or a converter that is used to convert to UTP. So it has 2 points. One point where you connect with fiber, and then the other point where you connect with UTP. So the one that you connect with UTP, that's the one that goes to your computer or to the other end device that is this side, the same as on this other side, okay? Let's just move on. Here you can read more. I'm just, this explains exactly what I'm just from looking at there. Okay. We have, so for you to work with fiber, if you are working with fiber, you use, remember we had looked at fiber modems. Okay, so for you to connect longer distances, which can support maybe, which are more than 100 meters, you may need to use fiber, which can span kilometers. I've said fiber can be connected from Kitwe to Ndola. But when you reach the other building, you may need to use a fiber modem to convert back to UTP. So we've looked at how you can extend a local area network by using fiber modems. Now we are going to look at how you can extend a local area network by using what are called repeaters. Okay, so an electrical signal becomes weak as it travels. We've looked at this. So to overcome such limitations, some local area network technologies allow two local area networks to be joined together with a device known as a repeater. So a repeater is usually an analog electronic device that continuously monitors electric signals on each local area network. When it senses a signal on one local area network, the repeater transmits an amplified copy of the other side, on the other side. Here we have a local area network here. So this is, let's say you are using, on this side on the left, let's say you are using, what is this, UTP. And on this other side, you are using UTP. This is, let's say 95 meters, and you don't want to go beyond 100 meters. And then you want, your network still has to join. You can use a device called a repeater. So basically what the repeater will do is, it will get a signal that is coming from this wire, amplifies it, and sends it to the other side. So your network will seem as if it's one. The signal will still be maintained at the strength it was through this repeater. So the repeater will basically just get what is this side, amplify it, and send it on the other side. So a repeater R, which is here, connecting two Ethernets, which is Ethernet 1 and Ethernet 2. The repeater connects directly to the cable. So it connects directly to these cables. Repeaters do not understand the flame format. How the flame is, they don't understand things like MAC address, those they don't. Nor do they have physical address, they don't. So all they do is amplify the signal that is coming from this cable and send it to the other cable. That's all they do. Okay? You can read more on what is here, but I've explained basically what that means. Okay? If you have a story building, let's say a building that has first floor, second floor, and so forth, you can have one straight wire like this. And then for each floor, you have a repeater that is sending to that segment on that floor. So when it sends, there's a repeater, because if this is too long, there is need of this repeater which will burst and send to a network segment. So a repeater can still be used in such a building whereby you have this one long cable where each floor has a repeater that is used to replicate the signal and send to the various computers on that floor. So repeaters have, in as much as they are good, they help us to extend a network. But repeaters, we should know to say, they also have drawbacks or disadvantages. So we said repeaters do not understand anything to do with flames. They don't know where a flame is coming from or where it's going. All they will do is, something is coming from this cable, send it to the other cable. Okay? So a repeater does not distinguish between a valid flame and other electric signals. So all it does is, I've received something here, send it this other side. So when a collision or interference occurs on one segment, a repeater will still retransmit on the other segment. So including an overlapping of signals, a repeater won't even not say there's a collision. What a repeater will do is, what has come from here, get it, boost it, send it to here. What has come from here, get it, boost it, send it there. It won't detect if there is an error or not. All it cares about is, let me boost the signal and send it to the other side. So we've looked at two issues. You can connect your local area network using fiber modems, using repeaters. Now we'll look at how you can connect your local area network by using what we call bridges. Just like in an ordinary road, you bear with me to say a bridge helps you to connect from one end to the other. Let's say there's a river, you may need a bridge to connect from this other side of the road to this other side of the road. So like I've always said, when you're looking at computer science, guys, you don't need to be thinking of words the way they are not, okay? So when you're looking at computer science, guys, always think of words the way you relate to them in everyday life. So when you're looking at a bridge, it's basically the same bridge, just like the bridge that you use when crossing from one side of a river to the other side of a river. If there are mountains and you're trying to move from the other mountain to the other mountain, there are bridges as well that you can use. That's the same concept that bridges in IT or in computer science refers to. So a bridge is a mechanism that connects two local area network segments and transfers packets between them. A bridge listens to traffic on one segment in promiscuous mode on each segment. What we are saying is when it receives a frame from one segment, let's say from segment 1, the bridge verifies that the frame arrived intact or correct, and then forwards a copy of the frame to the other segment if necessary. Get me clearly? So for a repeater, we said all it does is it gets something from this segment, boosts it, sends it to the other segment. Whether it's not correct, whether it's correct, whether it's intact, all it does is push that particular data there. Okay. If this frame had to come from here, if it's a repeater, all it would do is get it, boost it, send. But for a bridge, what we are saying is, if let's say a machine which is connected to segment 1, this cable, sends something, what the bridge will do is it will check, is this frame intact, by using things like CRC. Okay, so a bridge is more intelligent than a repeater. I may ask you such a question: what's the difference between a bridge and a repeater? So a bridge is more intelligent than a repeater. Why? Because for a bridge, what we are saying is when it receives a flame from one segment, the bridge verifies the frame arrived intact. So it will verify, is this correct, by using things like CRC. If it's not correct, then it will discard or drop the packet. If it's correct, then it can process it and send it to the other side. Apart from that, if you've checked this part, it's saying, and then forwards a copy of the flame to the other segment if necessary. So if it's not necessary, what a bridge would do is it will drop a packet here. Why does it have to drop a packet? Imagine this computer YU there is trying to send something to a computer W, which is on the same segment as this computer. So if computer U sends something to computer W, there is no need of sending it to this segment because W is on the same segment as U. So immediately this bridge knows to say this communication that is coming on this wire is meant for a machine on the same segment as the sender. Then it will drop it here because it knows to say even the receiver has gotten that packet. It will only boost the signal and send it to the other side if it knows to say the receiver is sitting on the other side of the network. But for a repeater, all it does is get, send. But for a bridge, it's more intelligent and it will always check the packet. Is it correct? If the packet is correct, is the receiver on the same side as the sender? If yes, it will drop. If not, then it will send on this other side. Okay, I'll still get back to that to explain something. This same concept of flame filtering. Flame filtering is the most variable function a bridge performs in flame filtering. So a bridge does not forward a frame unless necessary, like I've said. So if a computer is attached to one segment, if a computer attached to one segment sends a frame to a computer on the same segment, the bridge does not forward a copy of the frame to the other segment. If the local area network supports a broadcast or multicast, the bridge must forward a copy of each broadcast or multicast. So when a frame arrives on a segment, the bridge extracts and checks. It checks for what? The destination IP, the destination MAC address. Is the destination MAC address on the same segment as this? If it is, then it will drop. If the destination MAC address is on the other side, then it will send the signal on the other side. So if a bridge knows that the destination computer is attached to a segment over which the frame arrived, the destination will also receive a copy of the transmission. So the bridge can discard this particular frame. I'll leave this for you to continue reading, but let me just go straight to the explanation. What are we saying when we say frame filtering? Okay, so what we are saying is when this bridge switches on, maybe your network was off, power was off, then you power it on. It will try to communicate to all the machines which are connected to, let's say it's left or it's right. And then it will send them a message so that it knows what their MAC addresses are. Because remember, when you're sending on a local area network, a MAC address is important. So it will send and then know to say, okay, on this side, I have W as a MAC address of A, B, C, D. On the segment 1, I have machine V with a MAC address of this, machine U with a MAC address of this, the same as this side. So as it comes on, it will know the MAC addresses of the machines that are connected on which segment. So when a machine wants to send something, it already has in its memory to say, if let's say W is a receiver, if you send something, it will not say, okay, U is connected to me using this port. So I don't need to send anything this side because I know W is on this other side. But if U wants to send something to Z, it will check, is Z on this segment? If Z is not on that segment, it will check, okay, where is Z? Z is on this other segment, then it will be able to transmit to this other segment. So when you compare the two, the bridge and the repeater, a bridge is more intelligent, okay? Let's move on. And then here I've even given an explanation of how the bridge gets to learn about the machines that are connected on the left or on the right. But in real life, there is nothing like left and right. I wish we had a physical meeting, then I can show you why I say in real life there is nothing like left and right. So these steps here just show you what happens as the bridge is trying to learn what is connected to me on this other side and what is connected to me on this other side. So you can read more on this and you should be able to get that clear explanation. Okay, here we are also saying you can read more, or now you can plan for a bridge network. So how does restricting propagation influence design? Mostly I won't ask you questions here, but I expect you to just read through on how you can plan for a bridged network, okay? I've also given explanation on bridging between buildings, how you can do your bridge between buildings. So you can as well use fiber to connect buildings. You've seen there's a fiber modem there, okay? So I can connect this network, use a fiber modem, use optical fiber, use a fiber modem, and then maybe from this fiber modem to the network here, maybe it's above 100 meters, I can still use a bridge there. So I can use a combination of modems, I can use a combination of repeaters and bridges just to join this cable, just like in this example. So you can read more as well there. And then, sorry, you should be able to find, you should be able to get clear. But like I said, even there, I don't expect much questions to come from there, but I expect you to just read and just brace yourself with more knowledge on how bridges work. Okay. Bridging across distances. Imagine you have a network from Kitwe to Ndola, and we are saying bridges work with mostly UTP. How many bridges are you going to use? There are a lot. So how can a bridge network span long distances? Two methods are popular. So each involves a long distance point-to-point connection and special bridge hardware. So one option, the first option uses a list serial line to connect the two sites. So you use of a list line is more common because it's less expensive. For example, like I said, there are those companies, even service providers that will have fiber laid from Kitwe to Ndola. So you can use that list line to connect your two long distance companies. And then when you reach at your destination, then that's when you bring in the aspects of bridges. But you can't have bridges from Kitwe to Ndola. That will be too much bridges because every after, let's say 90 meters, you need to connect these bridges. Okay. The next option that you can use is satellite. You can have two satellites. One satellite for your, let's say, Kitwe office, the other satellite for your, the other satellite station for your Ndola office. But remember, satellites are not that cheap to use. So the second option as well may not really be viable. But the first option, where you use a list line, let's say Zamtel has a line, you use that line, that one is more viable, and that's what most companies are doing in Zambia. But when we talk of satellites, we are not yet there because we've looked at how expensive satellites are. So for satellites, that won't be a good idea, if I may say. Okay. So basically, that's what I expect you to know in handout 9. The other things there, just read through, but don't expect me to ask you questions. These are just for you to get to be familiar with how spanning trees, how switching is done, okay? But don't expect me to ask a lot of questions from there. So if you have any queries, like I've said, always drop me something and I should be able to respond to that. So for now, I would say we should be good to go, guys. Huh? For now, we should be good to go. So I will be ending this video on this note. Okay, this other part I need you to read. Yeah, I need you to read just this part for your understanding because it's important. We've looked at the other three. Also look at switching and what you can just get out of that switching. Okay, so for now, that has been our handout 9. Let me just close handout 9, and then I want to just open our handout 10. Our handout 10, we are not having any session from it. Our handout 10, basically, what I'm saying is go and read on your own. These are self-explanatory. You have what is a network. The answers for what a network is are there. You have a local area network, what we've been looking at. What is a local area network? The responses are there. And you have explanations of what a local area network is. Apart from that, you have things like wide area network. What is a wide area network? A wide area network, we have explanations there. So you have a local area network, wide area network, as well as a metropolitan area network. You learn to know what the differences are, because I'll surely ask you questions to explain what a local area network is, wide area network is, as well as a metropolitan area network. Also learn, read through on what peer-to-peer networks are. Okay, read on what client server networks are. Okay, and then we should be done with our syllabus. So don't expect any video for handout 10 because everything is self-explanatory. The handout is just 4 pages. So in case you have any challenges on handout 4, that's when I may need to, handout 10, that's when I may need to come in. But Believe me, this last part is self-explanatory. That's under handout 10, which looks at networking concepts. Just read through, but be assured I will ask you some questions out of this. So for now, it has been a good day, guys. It has been a good evening. It has been a good morning. Stay blessed. Just continue reading through and watching. You can revise, you can repeat most of these videos that we've been doing. So just watch, just read, and then come Thursday, we should be doing our second test. And then on Thursday, I'll announce or we'll discuss when we can have our test 3. Have a blessed time, guys.